Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we have seen three models. Model 1, the level model, log level, and then level log models and the different interpretations each of these models takes on their coefficient. In this video, we're going to step into the fourth and last model, which is that of the log model, where we have ln of y equals to beta null plus beta 1 ln of x plus an error term. So notice in this case, we have both the y and the x in logs. The last model, we're going to call also the elasticity model, which compared to model 2 and model 3 were just the semi-elastic models. So that means now we are moving completely into percentages interpretations. And I'm going to have you recall the key log property that we've seen in another video, which was that any changes in the ln of y approximately equal to delta y over y, and any changes in the ln of x approximately are delta x over x. So both sides represent percentage changes. So what would an interpretation for the log-log model look like? The interpretation would be as follows. So beta 1 hat measures the percentage change in y associated with a 1% change in x. And this is also called elasticity. So beta 1 hat is an elasticity. More concretely, we can say, imagine that we've got beta 1 hat being equal to 0.6. The interpretation that we're going to give to it is that a 1% increase in x increases or is associated with an increase in y by approximately 0.6%. So look, I am just literally taking the beta 1 as it is. So 0.6%. Now suppose that beta 1 hat is actually equal to minus 1.2. The interpretation to this will be that a 1% increase in x increases, or the best way is associated with an increase, with decrease, y by approximately 1.2%. Now, the reason why I'm putting this negative value in here is because of a very simple misconception that sometimes creates. Keep in mind, just because you're using a log-log model does not mean that what you estimate cannot be negative. Where is that misconception coming from? Well, when you convert a variable into logs, so if you have the log of a negative number, obviously this is not going to be possible. So it's not allowed. We don't have like a log of a negative number. So from here, a lot of students think that, well, because everything in the logs is the log of a positive number, then beta 1 cannot be positive. And that's not true. Just because the numbers are positive does not mean that the relationship that you're looking into is not negative. And keep in mind, beta 1 hat is the interpretation on that relationship. So even in a log-log model, your beta 1 can also be negative, okay? So negative elasticity is completely allowed. Now, why is this model so powerful? Why is it so well liked in econometrics? And one of the reasons for that is because the model assumes that the elasticity is constant. That means that the percentage response of y to x does not depend on the level of x. Okay? So the percentage response of y to x does not depend on the level of x. Okay. So how does it really contrast with previous models that we have seen? Well, in model 1, we have a level model, and one of the things we liked about it was that we had a constant unit effect. So it didn't matter if you changed from unit 8 to 9 or unit 100 to 101, that effect would have been the same. In log level model, we had a constant percent effect of x on y. On the level log, we had a constant unit effect of percent change in x. Now, the log is a constant percent effect of percentage change. Okay? And that sort of concludes this whole arc of all the interpretations that we have seen. For model 2 and 3, we had like multiplication or division by 100. But in the log model that we have in here, it's just like in the level model. You don't do any division, no multiplication, just read it directly. Okay, so just read directly. This applies to model 4 and to model 1. The only time, again, that we had to do any modifications was for the two semi-elastic models. I hope this video was helpful, and I'll see you in the next one where we do the mathematical derivation of the log model. So stay tuned, and I'll see you in the next video.